Hello, good morning. So, yesterday, the end of the session, we created an orders table, and it is well, time to build some of that stuff. So, gotta think about what to do. Uh, Getting my brain started in the morning, thinking to have a simplistic catalog. I think a simple thing to do might be to create some sort of, add to cart button to put here. Click add to cart. It'll put it in your order. Be one thing to do. Maybe another approach to do would be to go to the seeds and create some seed data of an order and create some pages to look at existing and past orders. I think that might be what I do first. Build out what it looks like to already have orders in the system, and then do adding to cart after I have some of those things worked out. I think I'm going to do that. Excuse me. So I can go to my to do. Let's go down here. We've got working on orders. And we had create schema. We've done. And do. Yeah, so I'm thinking there would be like a probably a button on the nav bar that you can go to look at your current and past orders, and that might show you like a little number counting up how many items are in that order. But also, like once you click on that and look at your active cart, you'll see a list of all the items and the quantity, the price, and some sort of button to go check out or something like that. And in that page, you'll have buttons to uh, update the cart, remove items from cart. And so I think there's actually a lot of work to do just on that page. Uh, and with seed data, I can set up the data for that page without having to build the actual initial add to cart button. And so I just think there's going to be a little bit more to do on the actual order page first. And then once that's all done, layering an add to cart button onto it feels simpler to do. This is something I think like some ways to think about application development is maybe parallel timelines. I would say like user story. The user story is definitely going to take a pretty clear path of add to cart first. Smaller. Yeah. Like user is going to add to cart. Then they're going to go to the order details page. Then they're going to go to checkout. They're kind of always going to have to go in this order. But so let's say user story 1, 2, 3, but the build story isn't stuck going in that order. The user has to go in that order because there's no order details page until you've built it, but the build story we can put in any order we want to. And so I like to often take advantage of that. Depending on this, like it might even be, I might even want to do the checkout next. Because I think about this as like this is a harder thing to do. Uh, it's also really important. Like another way that I might think about it is the user story order uh, has a fixed order. The build story order is up to us. And things that I might consider in the build story is difficulty, uh, say like centrality. So the order feels more central to what the application is doing than adding to cart. Uh, and then I also might think about importance of quality. So the checkout process, I think, has incredibly high importance of quality. Like this is where we are taking money, and once you go to checkout, you have an expectation that we're actually going to send you that product. I want to say, yeah, difficulty. I think it also ranks pretty high on difficulty because we have to interact with payment systems. If we have an inventory system, this is the point where it's really important that we don't uh, sell the same product to two people. Um, we also might have like we might be sending an email. This might be like one of the first points that we send an email. And so I say like difficulty, which is pretty closely associated with like size or effort. And if possible, I might want to do these things first. Uh, one of the reasons is a little cynical, which is that if I'm building this and I have a fixed timeline in which I need to build this thing, uh, the natural tendency is that you will take all the time that you get, possibly, and then some. So the later you are in the project, the more time pressure you're going to feel to rush things and cut corners. So if you do the hardest things first, which have the highest importance of quality, you are going to take the most time with those things. When you get to the end, like if I'm in my last week and I've got to get a bunch of stuff done, I really want those things that I have to rush through to be the smallest and have the lowest importance of quality. That if I need to cut corners, I want to cut corners on the add to cart button more than I want to cut corners on the checkout flow. And so the I think the high risk in planning software development is that we do a good thing, which is we use our empathy and we put ourselves in the shoes of the user and we walk through it and think about it in user order. And then we might potentially decide to build it in user order. And in the case of e-commerce, I think building it in user order creates some really high risk that we get to the end of the project and we haven't finished the checkout, and then we start to rush it. And then, since it was the most difficult thing to build and we built it under the highest time constraint, the highest time pressure, we do some really weird stuff in there and we are unhappy later. Yeah, I think about it in terms of like, if I have to half-ass something, I want to half-ass the cart page, or I want to half-ass add to cart. And even order details page is probably not that complex. I hadn't been thinking of doing this, but I might actually go ahead and build checkout first. Yeah, starting with the most difficult. It's not always the thing to do. Like, you might have a better division of labor, so you might be able to get more people doing more things. But I think at least as early as possible in the project, someone should be working on the most difficult things. So I'm going to do it. I'm going to go ahead and do checkout first. I'm going to totally work backwards here. Uh, and so to do checkout, I'm going to need some seed data for an order. So let's go to, all right, so we're going to create the schema. We're going to build checkout flow, which means we're going to have to uh, take payment. I do want to send an email. I'm going to go all in. I'm going to do a lot of stuff here. We need to take payment, need to send an email, uh, need to mark order as closed. Yeah, we already have I put the column in place for uh, the order status. And so, at least for now, I'm just going to use open and close to indicate that someone has taken an order and paid for it. We'll take payment, we'll send an email, we'll mark the order as closed, and that's pretty much it. Then, after the checkout, then we'll go and have an order detail page. And yeah, I'll probably go look for something like Stripe. I think Stripe makes this pretty as painless as possible, and they have good support for running like test payments. So I can do that legitimately. Excuse me. Okay, I'll have order detail page. Will include modify quantity, move items. I want to cancel order, begin checkout, and then we'll have uh, add to cart, and then we'll have some sort of cart size indicator, and then some sort of order history. So you can go back and look at stuff. And then I'll have to go figure out what to do for people who aren't signed in. So let's go. Yeah, application development. There's so much of it. Think, oh, we're just selling stuff. Okay, so to take payment, I need to have an order in place. So I think I'm doing this in my test setup. I need to get better names for these. Global test setup. Yeah. I am going to, okay, so this branch was just called add orders table. And I am going to go to GitHub and get that merged in because last branch ran longer than I wanted it to. Okay, so that already merged in, which is good. And then uh, I just realized I wanted to rename these files because these are not helpful at all. So let's make a branch to rename test support files. And so this setup test is really doing, I think I'm going to do is I'm going to make, close these folders for a second. Is I'm going to make a folder in my source directory called test support, because I've been giving these camel case names. I'm going to move these files into test support so that I know what they're for. I have to go to vtest, and these files are now in new locations, but I'm going to rename them as well. This import changes. So this is uh, defining mock service worker. So this is going to be uh, setup mock service worker. That's really clear what that does. And this file, don't need, this is not used anymore, but this sets up the seed database. I'm going to say setup seed data. This really setups test data. Yeah. Create seed data. So then I'll go to the vtest config and change these to be source. I think I can do copy relative path, and that'll give me the full path. And I think that's the order that I wanted to do them in. So then we will, that's the dev server, make sure the tests still pass. Okay, that looks good. So then I will check my Git status, add the source directory, add the vtest config, commit, uh, rename test support. So this commit renames test support files to indicate what they do. Push that up. Wonder, I have some extensions installed for GitHub. Are Git lens installed? Does this show me pull requests? Not sure. Do I have GitHub? pull request. No, didn't do anything. Let's go to GitHub properly. So it was confusing. I rarely knew which file to open to find the test data. Create that pull request. Enable auto merge. You have to go switch back to main. So this does create some noise. I have to wait so long for this to pass. A huge amount of time. I'm not going to go down the road of installing these, but there are some tools uh, that help manage your Git repository. So I know of NX and Turbo Repo, and these are tools to help you manage your repository and these are mostly useful if you have a much larger project, possibly many people working on it. Often if you have multiple projects that you're maintaining in the same repository. When I say multiple projects, I mean things that deploy separately. So if you have a back end and a front end, or if you have a bunch of internal projects, like I'm getting all of my modules from NPM, but inside of a larger workspace, you might have modules, reusable code that you use within your company that are only in your company. But they're structured more like they are a library, like an installable thing. And so you might have one repository that has several pieces of deployed software and dozens or hundreds of little packages. And so that's where a tool like Turbo Repo or NX, and I'm sure that there are others that do this kind of thing, help out. Uh, and so one of the things that I'm sure Turbo Repo must have something like this. One of the things that NX does is they help make sure that you don't have to run your tests again if you've already run those tests. Uh, and so, like, if you run the test on your computer, once it gets to CI, there's no reason to run those tests again. Uh, and so it can save quite a bit of time. But I'm probably not going to go through the effort of installing this right now uh, because it does take a little while to set up. But that would be an option if I was frustrated that every time that I want to do this pull request flow, I have to wait a minute. Might be able to get that cycle time down to, 10 seconds, 15 seconds instead of 2 minutes. But I have uh, spoken long enough now. Uh, got that done, got that out of the way. The Yeah, yeah, it sort of optimizes several things just by keeping track of where have the tests run. That if the source code hasn't changed and all the tests pass, there's no good reason to run those tests again. Uh, if there's any randomness in your test suite, you've already lost. You want pure determinism, that if you have the same code and the same tests, they should always pass or always fail. Uh, it's not always the case. Sometimes there are problems, and then you have to go fix those problems. But you don't want any randomness in that test suite. Uh, so what? All right, fix that problem, and then let's go git switch create checkout. And so I wanted to go into my test support, modify the test data. Be happy that I renamed that file. Uh, so I've got a seed user, and I know who they are, and I want to create an order for them. Really curious to know what Copilot thinks it's about to do. Oh, hey, we're going to create an order. Uh, this is not exactly correct, but I'm curious to see what's going to happen. I might be able to just fix some of these things. A lot of fascinating order data here. Uh, so I don't especially want all this data. Eventually, I might want more test data, but for the moment, I'm just going to create one. And I also know that I made this, I call this open. The user ID gets an open order. User one gets an open order, but I actually don't know that I want to give this to user one. I want to give this to this user. So let's see, what does seed user return? Seed user returns nothing. I guess I'd like it to return the actual user data that we got back. So I want to say returning star. This is going to return a user record, and I'll actually have this return. So that on this end, I can get the rows test user, and this will be an instance of user. And then here, when I do this create, I can actually fill in that test user ID. And then I want to do the same thing here. I missed a step. I missed a step because I don't have this built yet. I needed to do I needed to regenerate my types. Let me see, I need to restart TypeScript server. No orders. Orders should be in here. Let's see. Yeah. Okay. So we'll create an orders. I want to do the same thing here, returning star. Renew const rows test order there. And for the order items, I'm going to say order item, product ID, quantity, and I also had, I believe I put sale price in here. So I'm going to say, I guess in theory, I could predict what the user ID is here. And here I was just doing that. I wasn't actually pulling that data back out. I was just saying for products categories, I knew that I had 4 of each. I'm gonna not try to make this too internally consistent. So we will say order ID will be $1, product ID 1. We'll have one of those. We'll make the sale price the same. And then we'll get product 2. We'll have two of those at 200. Yeah, why not? We'll have 3 at 300, 4 at 400. So we put every product into our order. I think that, and then I'll have to put the test order.id. This seems okay. The reason why the reason why I prefer using the actual values is just a little bit more, a little less brittle. So if I happen to move this code here, or if I just want to rearrange, no, not this code, if I wanted to rearrange this, so I'd put like the test user here. Now the IDs are going to be different. Uh, but so this won't break because I'm getting the ID that the database generated back out. Uh, I'm not going to be too picky about that, but there's an advantage to actually getting the actual ID back out of the database versus just predicting that it's going to be that way. Because if I restructured my seed data here and I ended up getting different IDs, then I could break those tests might fail for reasons that I didn't want them to. Uh, but I'm going to tuck that thought away. Uh, let's, oh no, take a look at these tests. So what did I do wrong? Oh, I forgot. It said syntax error near dollar on 49. Um, I don't know why it's saying the failure is there, but it definitely looks like that is a problem. I didn't say which you're able to do there. Hmm. Store.orders does not exist. That's right, because I made a different schema for this, called it the order schema. Syntax error at or near order. Oh, and I think I had to call this orders because order is already a keyword in the SQL language. So it didn't like that I was using that same thing. And then order items does not exist because I called it line items. We're getting everything today. All right. So that works out. So let's go to, I want to make, because I'm trying to test this thing as much as I can as the user would use it. So can go and make a checkout page. So let's make a page here. Our checkout page. We'll make a test for it. Vite will complain that there's no tests in this file yet. We'll describe checkout. And yeah, renders a form for checkout. Why not? mostly doing this so I can get my skeleton put in place. Import everything. I don't actually know what I want all that to look like. And this test render is not promise-based. I don't know, Copilot, you're suggesting things that don't exist. And we'll do export const checkout equals something that will turn just some empty JSX fragment. And we'll import that here. And save that. So now we have a substrate to work in. What am I gonna have this do? Well, let's think a little bit about what this checkout page should look like. So we've got checkout, and I suppose it would make sense, I think, that you'd get a little indication of what you're about to order. Yeah, order details. So I want some. I'm going to make that pretty brief, just something to tell us something about it. And then we'll have like the quantity of that, and the price, and then probably want to see the total. And then I guess we've got a question here, which is for the checkout, do we just do one big ol' page? Hmm. So we have this question of like shipping. Do we ship our products? So do we need a shipping address collection? Do we need billing address collection? We might need to do those things. I think I'm going to punt on that information until I know exactly what I need for it. So I can kind of delay, I can defer dealing with shipping address for a moment. Yeah, the payment is really the thing that I want to get to. So I'm also going to defer thinking about billing information until I know exactly what Stripe requires of me. And so I think, yeah, we can just see the order information and a nice little button to pay. And then that's going to do some sort of Stripe thing. So we'll go Stripe, we'll do something, and then in theory, we're kind of done. So I guess maybe now's time to go research Stripe e-commerce payment. Set up payments in minutes. I like taking minutes. I wonder if I already have a Stripe account. I have to generate the password. It'd be fun. Do this on a different screen. Getting a password generator to generate a password. Just another second. Getting that password. Place. Okay, I've got a nice big password. Already signed up, but I'm going to make, so this is, I don't know if Stripe's going to play ball with this, but Gmail, if you have a plus after your main email address, it'll still deliver this to you. So I'll still get emails from this, and Stripe might consider it to be a separate account. Yeah, so I am still. This is also like a good way to figure out who's selling your email. I mean, some systems might be wise to this now and like strip it out. But if you're ever signing up for something and you're wondering, hey, if you add this, and then if you ever get an email with that plus, you're like, hey, I know that you are using that email and I know how you got it. Uh, so now I'm just going to look at my email to verify. Doing that on another screen. Okay, so I have verified that on another screen, and I'm in. Yeah, it can be anything after the plus. I'm gonna assume not another plus, but yeah, just anything at all, and that email will get routed to whatever you put before that plus. Kind of gets ignored for purposes of delivery. Okay, so let's see. I am in test mode, which is good. Let's see all of the products that we have access to. Send an invoice, share a payment link. Banking, do payments. Oh, there's a nice friendly developers button up here. Uh, Make a test payment. Okay, let's do Stripe React integration. React Stripe reference. Stripe.js. React Stripe.js is a thin wrapper around Stripe elements. Allows you to add elements to any React app. This is what I'm looking for. Get to do a cool load Stripe. Drop a payment element. Gotcha. So I create a form. I put a payment element in that form, and then stuff happens. Do confirmation. Yeah, this is each element is mounted in an iframe. They recognize that iframes make styling an element more difficult, but they shift the burden of securely handling payment data to Stripe and allows you to keep your site compliant with industry regulation. Seems fair. Can do all kinds of integrations there. Now I know there's other ways to do payments. They want to accept online payments. Yeah, there's this like form where they sort of just take you to an entirely different page. I might want to do this one. So this is using Ruby. My front end is React, and my back end is Node. Let's see what they say about this. So what are they doing? So you install the Node Stripe library, and then you create a checkout session. Yeah, so this is smart what they're doing. So we've got a handful of systems that are at play. So we've got our front end, which is built in React. We've got our back end, which is built in Node, and we have the Stripe backend, which is we don't know what that's built in, but it's theirs. And some important details is this side, this is trustworthy. Our backend and the Stripe backend are running on computers that are fully under the control of Stripe and fully under the control of this. This is, we have like a thief, robber? No. Put a ghost here. This is the shady zone uh, because we are sending code to run on other people's web browsers, and then they are sending HTTP requests to our server, and they could lie about the information. So the trouble is, we are going to have our front end start to interact with the Stripe backend, and they could also lie to Stripe. So what we're going to do is we're going to have our backend. The first thing it's going to do is it's going to send a message to Stripe, and it's going to say like, "Hey, customer, like Colin is about to pay, like let's say $200 for stuff," and then Stripe can send us back a piece of information, which is like, cool, here is a secret, like a key. Stripes is like, cool, here's some information to send to them. And then we send that key over to our front end. The key goes along there. Make these, they're all going to be going that with us. And then the front end will communicate to Stripe, and they have to send the same key. So the front end doesn't have the opportunity to do things like, say, determine what the price should be. This is kind of like kid says, "Hey, Dad, Mom said that I could have ice cream," uh, and then Dad says, "Cool." Uh, Kid gets ice cream. Uh, what should happen is kid says, "Mom," or says, "Dad, Mom said that I could get ice cream." Dad goes asks Mom, "Did you actually say that the kid could get ice cream?" So it's this verification here that we have two trustworthy parties that are sending messages through an untrustworthy party. And so they have to coordinate first. So that's what's going on here with this checkout session, is that the first thing what we're going to do when you start your checkout is we are going to tell Stripe, and that's what we're going to do here on our back end. We're going to say, "Hey, Stripe, uh, we would like for our customer to pay a certain amount of money for some products." And then Stripe will give us back uh, some bit of information that the customer can pass back on to Stripe. So that's what the payment session is going to be. This is interesting. So to create a payment session, they're doing this thing with like, this could be a lot more work. So they're using predefined price IDs or on the fly with price data. I think I want to use price data. So I don't want to have to put my entire product catalog into Stripe. Price data currency, price data. Yeah, so I'm gonna have to do price data, which will be interesting. And then I have to pick the mode, which is going to be payment. And then I'll need success and cancel URL. So this is once the payment has been made, Stripe is going to send people back to my app uh, and say whether or not they have succeeded or not. And then I redirect someone to the checkout. Customize the checkout page. Nice. So I can send some. Oh, fun. So Stripe will even do the billing and shipping address collection for you. That's pretty friendly of them. You can do tax collection stuff. This is great. Okay, so I'm gonna get started here. But you can see, yeah, this is so complex. There's so much going on. Happy that I started with this one. So I'm gonna have to install Stripe. So let's do that. Got Stripe installed. Uh, I need to set up my Stripe test API key. So that's going to be something that's going to have to go in my environment. So I'm going to add that to the environment example. This will go into the secrets section, Stripe API key. And these will look something like SK test and then, long sequence of characters. And I'll say, we gotta find the Stripe API key in the Stripe dashboard. Only use test keys while developing locally. Do that. So then I want it to go to my actual environment and add the Stripe API key to be that one. Now, other payment processing tools. Well, off the top of my head, it's a big industry. I know there's PayPal, Stripe. Some of them are sort of, yes, Square uh, would be an option. We could go and just sort of take a quick look at how does Square do it. Uh, Take payments, accept payments in your application. They have a create payment. So their system, like where have this is probably the equivalent of the session, the payment session. I'm not sure, but they're all going to be somewhat similar because ultimately all of these are tools for interacting with the financial system. So even though they may have designed their API slightly differently, the end result is they are talking to a bank or a credit card company, and the banks and the credit card companies, they are regulated and consistent and as much as possible interoperable. So there's really, yeah, doing the same things. And like as much as markets can be efficient, I'm sure financial markets are efficient as heck. That they are the one part of the economy that like really they're the money people, so they are doing whatever they're going to do. Uh, so the way that these businesses can really differentiate themselves is in their documentation. Like they companies like Stripe, Square, PayPal, they need to get developers and businesses to use their tool to interact with the financial system instead of another tool to interact with the financial system. So they kind of live and die on their documentation and their brand quality for being a good system. And then I'm sure in terms of pricing, they're actually probably all competing very, very well. Uh, I probably, if this was a real business, we'd have to like have somebody go and validate that we're not going to spend a lot more money on Stripe than we would on Square. Uh, but I'm not too concerned with that right now. The Excuse me. So where were we? This one. So we got Stripe installed. I've got to do this thing to initialize my Stripe client. I have to uh, yeah. So what Stripe is going to do? You can go look at that. So they have this pricing. So they're going to take 2.9% plus 30 cents on every transaction. And that's just their standard. Uh, as I'm sure all these things are, once you get to a certain size, you just call them on the phone and you're like, hey, how much are we really going to pay? Because this 2.9% plus 30 cents is a lot. The Square pricing, They do free. Uh, there must be. Oh no, so that's $0 a month. But what is their per transaction fee? Yeah, they're 2.6. Okay, so online they're exactly the same as Stripe. 2.9% plus 30 cents per transaction. 2.9% plus 30 cents per transaction. So this is what I'm saying, right? Very efficient market. They are pricing themselves identically. Uh, yeah. And I think like that 2.9% plus 30-cent transaction fee, like I think some of that is just like the like credit card is a weird business. I don't know all the details of it, but I know that like lots of people are making these small fees along the way when you do credit card transactions. Uh, and so just a question of like who sees that fee, who pays it, and who gets it. But yeah, I'd be curious. Like there might be as far as if there's somebody who's doing a slightly lowest. So let's do like online payments lowest transaction fee. It's the cheapest way to receive payments online. Automated clearinghouse. Six cheapest payment gateways. That's interesting. I've never heard of this, but they seem to have wildly lower fees. Braintree is a little bit lower than 2.9%, but they charge a higher per transaction fee. Aiden has a higher percent and a lower transaction fee. Yeah, what is this? Why is this so much of a lower cost? Like that is significantly less. Uh, okay, that website was incorrect. This is much closer to the I don't know where they thought this was 0.5% online. This is 2.5% and 25 cents. That is a little bit less than Stripe and Square, uh, which I take to assume that they are right. They are just using that pricing to compete, right? It makes sense. I've never heard of this. So lowering your price in order to get more people to use your tool makes sense. I wouldn't be surprised at some point if they ever grew to be large enough, they might start to not compete on price uh, and find themselves in that. But they're very close to the common one. I'm kind of curious since we're here. What does their online checkout look like? I want to see what are they? Seattle start selling online for less. What does their cart look like? How do I get started with online checkout? Solutions, APIs, view the API docs. So you get a API token, that's pretty simple. Payment API, card purchase, if I'm doing Node, yeah, you have to get a card on file. Card verify. Interesting. So they have this checkout session initialize. Yeah, so this is they have the same checkout session idea. So you say initialize a checkout session. You say what the price is, what the currency is, and pay through credit card. What does the response look like though? It's interesting that the documentation is you get a checkout token back. It definitely looks like the yeah, they're a little cheaper, but they're not as good. Uh, and so, like, nice thing about Stripe is give you an entire checkout screen, and they will collect billing and shipping addresses for you. They are a much more substantial product, and so it becomes a question like if I was going to use this tool, I would have to do more work. Uh, Maybe not a huge amount more work, but I have to do a little bit more work. Uh, and so it's that question is like, is that our rates? Is that 5 cents and quarter of a percent worth it? I guess it's just from 2.9%. It's like about half a percent. So is the 5 cents and half a percent worth it to me? Uh, I think right now, I mean, this is a made up project anyway, so it clearly that doesn't matter. Uh, yeah, I say it's going to depend on like how like what is my margin like. This is becomes like a business analysis question. And from an engineering perspective, I'm almost always going to push for let's pay a little bit more and do the thing that lets us get this done faster and better with less effort. Uh, like one way to think about this is how much are you paying the engineers that are building this? Uh, right? If you are, let's say, engineer salary, I'm in Chicago, let's say, uh, I'm going to look like, so salaries could be anywhere from one to $200,000 a year. Let's go something like, what is this, 150 to hourly, like a $72 an hour rate. So let's see, what is 100,000? I mean, this is not a lot of money times point 0.2. This is 0.029. Be You're looking at, if we sell $1 million in product, we are paying $29,000 in processing fees with Stripe, plus whatever that, I'm not even going to guess what the 30-cent fee is going to be like. I'm not going to do that rich of analysis here, but their fees are 251. We go here to 251, $29,000 versus $25,000. So on $1 million of sales, we're saving $4,000, which, depending on what our engineering staff is like, we are saving a day's worth of work in terms of what we're spending there. And that's if we only have one engineer on staff. So we have one engineer working on this. Yeah, like until we're a very large business, it is the amount of money that we were saving here versus the labor cost to build all the other stuff that we have to build to make this work is just not worth it unless we really, $100 million. Now we're looking at, I guess we're going up 2 orders of magnitude. So we went from 4,000 to 40 to 400,000. Yeah, like we have to be making $100 million in transactions for on the percentage to even equal the salary of one employee that we'd save. So like if we did this and we saved that much money, we could hire one more person to work. Uh, and this is often like the way that you have to think about the engineering work that you do. Uh, because people, right, I wonder what is like, we've got an executive, and like, bless the executives. They're doing something. I'm not going to be too mean to them. We've got executives and we've got our software engineers, and they have very different set of skills, right? The executives, I don't know, they're good at shaking hands. I'm going to be real mean to them. Uh, what are they? I don't know. They're good at like filing cabinets. This is what an executive does. They shake hands and they run filing cabinets. And we're over here, we've got gears and electricity, and they can't do what they do unless we build what they need to get built. And they don't know how this works. And the things that we want is that we always want more time, we want more engineers, and uh, we want to have high quality system. Uh, I think we often want a high quality system because that improves our quality of life. So when I say high quality system, I mean like doesn't break in the middle of the night is a high quality system. So we want something that doesn't break in the middle of the night because that's going to improve our quality of life. We want something that uh, is flexible to future change. Uh, and what they want is they want to sell thing today is their primary motivation. And so if we want to get what we want, we have to be able to, persuade these people because they hold the budget, right? In order to get the things that we want, we have to speak in the language of what they want. So if we want to get more time, more engineers, I mean, yeah, if they want customer satisfaction, that's a beautiful thing. But they're going to prefer to sell the thing today. They're just focused on the next quarter, uh, or if you're in an early stage startup, they might just care about they aren't selling anything at all yet. I'd say customer satisfaction is going to be seen as a tool to get to sell that thing today. Uh, and so to get the things that we want, it's often very helpful to figure out how to speak in terms of getting the things that they want. So if I am like, you know what, in order to get more time, if I want to get more time, a way that I can get more time is to use Stripe over Helsim because Stripe does more stuff for me. So I go to the business team and I say like, hey, if we pay a little bit more for Stripe, uh, then we can get more things done so you can sell more things today. Uh, and right, they are often the audience for how we can plan things, how we can talk about, because I talked about like we're trying to figure out where we were, yeah, like here, how do we build things, in what order do we build things, and then also how much time does it take us to build things. Uh, but often the people who control the budget uh, in which we do that, they don't directly care. Like they care that something doesn't break in the middle of the night, only as so much as that's going to impact these things. They don't care that something is flexible to future change, only as much as it doesn't impact these things. Uh, and so talking about, right, like how much labor costs does choosing this tool, right? Choosing this tool has lower cost to use, but has an increased labor cost. Stripe has a higher cost to use, but has a lower labor cost. Uh, that's the language that I should use to tell this person that they should take on the extra cost of using Stripe. The real reasons why I want that because I don't want this thing to break in the middle of the night and I want future change and I want to build things other than a payment collection system. But I can't go to the people controlling the budget and say, my prime motivation in life is I don't want to build a billing system. They're gonna be like, well, why not? That's what I pay you to do. So I tell them, you know, I want to spend time building something else. I want to get you closer to selling this thing tomorrow rather than spend the 2 weeks to do it this other way. Uh, and so being able to explain your rationale, give your opinion, and especially being able to to differentiate like what matters to me, how does what matters to me translate into what matters to them? Uh, it's almost like, because we kind of want similar things. We just view it through a different frame, a different lens. Uh, and it would be important to understand what that lens is. Okay. Uh, so long conversation. We've decided to use Stripe. So where did exactly? All right. So I'm getting Stripe into my application. So I've got to do this. So we go into our server. I'm going to make a file. I'm going to make a separate file for this. I'm going to call this the Stripe client. So we will, that seems good, because I'm going to have to do import Stripe from Stripe. I have to do star as Stripe. No. I import Stripe. Aha. So we're going to do import Stripe. We'll do that. What is your complaint? Need to do new Stripe? No. Needs a configuration. And secret key might be undefined here, so I need to import .env config, and I want to, I need to make sure that crash if no key. So I just put that comment in there so that Copilot would write that code for me because I believed that it could do so. And then API version. Why do I need to set this? 22.11.15. We'll export. All right, Stripe, why do I have to set the API version? Stripe API version. Set a Stripe API version. Your account has a default API version, which defines how you call the API. I see. Because they make changes to their system over time. So I want to say, hey, Stripe, behave the way that you behaved on this date. Okay, that works for me. So now I've got my Stripe client all configured and settled over here. It means I can use it in my app. And let's go look at what they're doing. Pre-built checkout. So they've got checkout session. So I'm going to put some API in place. I'll make a checkout session. And what are we doing here? We've got our API router. So we'll go API router use checkout session. We'll have that be the checkout session router, which I haven't made yet. And I guess I'll make this, I'll call this checkout session. Got to import stuff, so we'll import router from Express. Checkout session router is that. And then we'll do a post. And I want to catch async errors. And now we'll do something like what they're doing here. Now I'll have to get my Stripe client. I'm gonna have to get my domain. Let's do, this is not quite accurate because it's not always going to be localhost 3000. It might have been deployed somewhere else. So what I should be able to do is do rec dot URL, base URL. Let's look at Express. JS get origin from request. How do I get the domain originating the request in Express? Can use the host header or origin. Request headers host. Request.hostname, which doesn't have the port. So I'm going to go, I'm just going to start with request headers host. Let's say host is that. And instead of your domain, we'll put the host in there. Session, why might this not have a URL? It might be null. So what are the types on session? Session.created. So this is a number. I see. So why is URL possibly null? I guess we'll do if there's no URL, and I have that crash for now. And then these other parts. So customer email. Okay. So for now, I'm going to need uh, to require that someone be logged in because I don't have anything to do with guests yet. So I'm going to go ahead and say const, what did I do? Auth required. Yeah. Let's say const user ID equals auth required. And then we'll do const user, rows, user equals await, select from users. Yeah, these are URLs that I provide to Stripe. So this is if, so we're going to say we create a session. Stripe gives us a URL, and we're going to send the user to this URL. And then after they either succeed or cancel payment, this is where they'll be sent back to us. There's going to be a handoff. We're going to send the customer to Stripe, and then Stripe will send them back to us. So we've got our user here. And then, so for customer email, we're going to do user dot, no, this is going to give us back a user record. We'll get their email address. Submit type is donate. Why donate? It's going to be pay. Billing address collection is automatic. Will allow US and Canada, seems fine. Mode is payment. What other modes do we have? We'll do payment, and we'll allow automatic tax collection. And then the tricky bit here is the line items. So I know that I'm going to need to get the order. So I want to say that the order ID needs to come through in the post body. Yeah, so let's go. So I'm going to need to do another select, but I want to get a schema here, like I'm doing with Zod for things like sign up and sign out. So let's say const checkout session schema is going to have an order ID, which will be a number. To import from Zod. How did I do this here? Yeah, I had lowercase there. And then I have to parse the body. So let's say const order ID equals parse body. So I've got your order ID here. So if you don't send an order ID, this will throw an error. Then we're going to get you user information. And now I want to get your order information. So let's say const rows order equals, select that order. And then I also want to get the line items for that order. So we'll do const rows line items. Select star from line items or order ID equals that. So this is getting gnarly and big, but I'm not going to worry about that yet. So I've got the order, I've got the line items. And now we want to construct this line items entry. So what do these stripe line items need to look like? This is the type. So I'm going to go grab this type and I'm going to say const stripe line items equals, and so stripe line items is this type. And we get that from our line items mapped. Oh, wonderful. I'm going to have to do some changes here, but Copilot seems to know plenty about Stripe. Okay, so I have to update these types. So this is an orders, and this is an line items. So now, oh, and I don't want to pull these out. I actually just want to have the full array. Now we'll map over the line items. So line item does not have a product name. We'll have to deal with that. And line item does not have price. Line item has a sale price. My question is, what is the unit amount in Stripe? So I am doing create a checkout session, line item, creating a checkout session, takes line items, line items data, currency description, price, so many fields. We're doing price data. I want to find in page. All right, so the line items data. Product data, price data. But I don't know about this unit amount. We're going to have to figure out, is this in cents or dollars? I'm storing my data in cents. So I might have to do some math there, but we'll see that later when we actually get into it. And then I don't have the product name, so I think I'm gonna have to join my line items on my products to get that data. So we're gonna say join store.products on line item product ID equals products.id. So I want to get everything from that and product's name as product name. And so I'm going to have to update my type here to indicate that we are also getting let's say and product name is equal to products name. Do products not have names? They have title. Okay. So this way, the type for this return, this is like a little obnoxious that like the type system doesn't really know about this join. Ooh, I can do something fun here actually. So let's look at our database. So my complaint here is that this is like I'm having to create this sort of type in here because I put a join in my line items. Uh, but let's go and look at something else that we could do. I'm going to grab this and go and look at my database. I'm going to go look at shopping cart test because this should have all the data in it. Yeah, this has line items and orders, and they're all in there. So if I select this, where order ID equals 1, products, this is store dot products name. That's right, it was title. So here, joined together, I get, I want to do line item dot star. There we go. I get this, grab everything so we can see it first. So if I do this join, I get all this information about the line item. Uh, and I think actually this is the, so I would have had, I think I have, yeah, so this ID is the product ID because the line items don't have their own keys. But like this is the actual thing that I care about when I'm thinking about a line item. Like the line item without the product information is not that useful. I kind of almost always want to have the opportunity to look at the full thing. And SQL has a uh, a way to do this. I can create a view, and a view is like a virtual table that corresponds to a query. So I can do create view. Let's call this orders dot uh, order products as. I take everything but the where and I put it in there and I run this and it says created view. And now I've got a special little table in here, but it's actually, instead of a table, it's a view. And so this is something that looks and feels a lot like a table, but automatically joins these two things together. And I can query it as if it was a table. So I can say select star from orders.order products, and I get that data. And I can do select star from order products where price is greater than 200, and I can filter it. So from the perspective of writing a query, the view feels just like a table. Uh, you can use through tables, you can use joins in views, but really views can be anything. So I can create a view. I could say like create view uh, expensive products as select star from store dot products where price is greater than 200 and create that view. And we can do select star from expensive products. And we only get the expensive products. So views are ways to, it's like, this is encapsulation again, right? I've encapsulated the idea of what is an expensive product. I've encapsulated it as this, like encapsulation inside the database. Okay, but I don't need an expensive products view, so I'm going to delete that. But this order products view, I do like that. I'm actually going to go do product star. I'm going to take this, I'm going to put this in my setup DB. So down here, I will do create view order products as select line item dot items, line item star product star from orders line items joined like that. Got checkout session router needs to be exported and then imported in here. So now the tests are going to run. I don't have a Stripe secret key, so the test can't run. I'm going to go to yeah, view table is really powerful. You can pretty much put any query in the view table. So it's kind of a way of just encapsulating so that you can query from the view without knowing exactly how it's constructed. And you can put pretty complex queries inside of views. They're very powerful. They can be a double-edged sword. You can put things that you shouldn't put in a view, but it's a very generalized tool. Missing Stripe secret key. Super obnoxious. Why is this .env not loading properly? Oh, because I said Stripe API key. This should be Stripe secret key. Okay. Let's get this up and running again. Okay, so I can rerun my TypeScript generator. And does this create types for views? Looks like it didn't, but I have to reset DB to get my generator. So I've created a view. The view should now be in the database. Yeah. And so this thing that looks at my database and generates TypeScript data now is aware of that view. Uh, okay, why does it think these are all unknown though? That is obnoxious. I want you to know the type of those. Let's go look at Postico and look at order products. Look at the structure. These should be known. Let's see if we can get this resolved. Kennel, view, type, unknown. Generate TypeScript. Let's see. Views. View. Error parsing view definition for view and falling back to raw data. Might be something like we're looking at. No. Oh, maybe there's some output here. Oh, could not resolve source. Schema orders, table products, column, whatever it is. I think this is why it's not able to find these, because yeah, ID, title, description, price, could not resolve source. So let's see if we can fix this problem. So let's go see, where does this message come from? Could not resolve source. Not in there. What does this depend on? I think this might be using packages, canel, package, extract PG schema. I think that might be the thing that's actually getting the schema out. Let's see about issues here. Error parsing view definition for a view. Needed a user with view definition permission. Don't know if that's exactly what's going on here. All right, I can't search unless I'm signed in. So let's go to proper tab. Hmm. So what's going on? Why can you not get type definition for this? Maybe do search for the word resolve. We've got to switch over. Okay, resolve source. That seems promising. Resolve view columns is what I'm trying to do. A lot going on here. We've got column source. I wonder, is this something to do with the order of the schemas? Because these schemas are referencing each other, and it might be doing them in an order where it needs to resolve this schema before it resolves this schema because they're joined together. Like canel RC, and can we do, how can we configure this? So let's go back to the documentation for this tool. Let's see, what does the configuration for this look like? Documentation, configuring, schemas. can be an array of string. So by default, I think it's just going to pick its own order for those schemas. But let's do this. I want to do users first, then store, then orders. No, still can't resolve it. I do orders first. So frustrating. All right, out of curiosity, I wonder what happens if I change the, like where I put this view. What if I put this view in store? Does it reverse where it can't find columns? Yeah. So that is tricky. So if we go to order products, oh, now it can't, now it's failing to get line items. Wait, order products. Now it's still showing these ones as unknown, but the output, it's saying that it can't resolve these. Regenerate these. Okay, yeah, that's interesting. So the schema, it's only finding the types for the schema that the view is defined in. I go to setup DB, and let's just say, what if I put it in the public schema? Will it find none of them? Let's clear out the types. What's going on here? Just look at shopping cart dev, make sure this all makes sense. Now order products still got in the wrong view. Let's put this in public order products. Delete the generated types, generate them again. I didn't reset DB. That's important for this. Now if I generate the types again, it can't resolve any of them. So it's super obnoxious that it can't resolve types for views across schemas. Frustrating. Why can't it do that? Go back. Resolve views. Oh, do I just have to tell it to resolve views? Is it that simple? said it can't resolve views. If you set resolve views true, it will attempt to give you better types for views. If a view returns, say, a column called account ID, what if I define that in a proper schema now? I go back to setup DB, move this back to orders. And then let's reset database, generate. No, it's not finding those. What if I'm a little more specific? What if I say orders.lineItem star and store.product star? And what if we say orders line item star and store product? So everywhere that I'm doing this, I'm giving the full name. No, still can't resolve source. Deeply frustrating. I'm telling it to resolve views. I think I do want this because this is I got confused once because it left a file in the types directory. I'm gonna have it pre-delete output folder true, so it'll always completely regenerate types. What other options do we have here? Enum style. Property sort function. Get metadata. Get property metadata. Generate identifier type. Hmm. So annoying. I don't want to spend an enormous amount of time doing this, but I'm just going to poke around a little bit more. This might be a genuine bug in this tool, which is not super surprising to me. I feel like it's not super common to take advantage of schemas in this way. Like very often, people will put everything in just the public schema. Uh, and so it wouldn't surprise me if a lot of people use this tool. Also, views are not a lot of people make a lot of use of views. I don't really understand. I think views are great. You can do bad things with views, but you can do bad things with any part of the database. I think a a wise use of views is possible. But let's look at generators. What was I looking at? Yeah, wonder. Resolve type. Oh yeah, I actually think this might be where the bug exists because this is where it's looking in the schema, but it's looking at the source schema and not at the schema that the table is defined in. Interesting. So I can do something a little strange, and I can go, I want to see what's going on here. So I can go to node modules. What was this file called? Resolve source generators resolve type. So I can go into that. I can go into the source code and I can modify it. Now they wrote it as TypeScript. They're distributing it as JavaScript, but I can go into that same code. So this is target tables find. And let's say we're doing console log resolve type. And then I'm going to save without formatting. And then I'm going to run this. And we get a lot of stuff. But let's see. Got name, order products. Let's see if we just do, I don't want to print out the config. I think that's giving us a lot more stuff than we want. Uh, okay. What are these variables C and D? Does this resolve function, composite property, composite details, what those are called? I'm going to put, so I'm just really exploring here within their source code, and I don't really know their system. I'm just going to put that there to break out all these different log messages. Let's see, where do they begin? Okay, so we call a resolve type, and then after calling resolve type, we get could not resolve source. Um, yeah, I might be able to, if I can figure out what's going on here, I might be able to send them a fix. So we're saying resolve type price, and the source orders products column price. Oh yeah, but this is wrong. There is no table called products in orders. This is looking in the wrong place. this should be looking in the store schema for the products table. So this information is wrong. You should be able to look at the hierarchy. We've got, so this function is called by this function. This just recursive. Hilarious. But I might be able to go, okay, who calls resolve type? Oh man. So this is, okay. I might be able to deal with this with some comments. Oh, that's target. I think target is incorrect. Oh, could not resolve reference. This is what I'm looking for. All right, I'm going to use, I can do node. Let's do console ninja node modules cannel bin cannel. There was console ninja. Yeah, I want that plus this because I really want to see. I was hoping I would get these log messages here. Start console ninja. No. Hmm. Can I run the script from there? No, but I am. So you're getting this could not resolve source. Oh, let's say could not resolve source. So I think we're probably definitely getting this one. So I'm just going to add a message here. Make sure we're really there. Run this. Okay, so we are getting here where there is no target. So where does target get assigned? Okay, this is a view with a source, so we're in here. Don't think I need those anymore. I think I can do, just put a debugger in there. And now I can do node options equals inspect break. And this should pause execution when we get there. Happening to save without formatting. Did not properly pause. Node options. Okay, so now I've got a debugger in place. So I can go to Chrome, inspect. and then play until it pauses. Why do I not see anything? Really would have thought it would have been there, but let's see. In there. My debugger is not working, which is frustrating, but I can just do some extra logging. So let's look at console.log source, c.source. I don't want the debugger anymore. Yeah, I think that these all come from the schema. They all come from the schema that the view is defined in. Let's see, if I run code on node modules panel, I'll get a new one, and I'm looking for the file resolve type. And then this resolve type function let's find all the references to this. So it exports a default. Sometimes it's called recursively. Okay, this was generate properties. It imports it and it calls it here. Or it might call it here. Type declaration, an identifier type. So I'm not looking for an identifier type. It might be this one. Oh. And these details come from generate properties. Who calls generate properties? The composite generator. Select your properties. This is looking close to what we're trying to get because we're generating an interface. And so the details from make mapper. Mapper is called the config. What are the declarations? Okay. I'm curious what happens here. So what are those details looking like? Well, I'm going to save without formatting. And let's, oh, already got that open. Let's run our generator. Yeah, we are getting details. And let's check if details, let's only do this if de details.name equals order products. Then I want to log information. So this actually happens after it can't resolve anything. Uh, Annoying. Oh, this might have to give up on this. Look a little bit more at what they do. I'm going back to their source code. It's a little bit easier to read. So when you run their thing, they parse some CLI options. Get a database connection, and then they call process database. So what does process database do? Process database extracts the schemas. So let's go look at process database. Which calls extract schemas. And let's look at schemas. Okay, the schemas happens before we get our problem. So that's useful information. And then it builds a bunch of generators. So it creates the generators for views. And then for each generator, it runs the generator against the schema. So I think this is where our problem is happening. So let's go look at for each generator. I'm going to do console log before generators and after generators. So let's see. Yes. So the problem is occurring inside there. And it's creating a composite generator. And then each generator is being passed each schema. So what is make composite generator? Gets a kind. tables, views, etc. And then it gets declarations. So let's look at what does mapper declarations look like. This is like peering inside the brain of the person who wrote this code. How do they think? So what was this? Make composite generator. If details.kind equals there's this one. Yeah, what are the declarations? All right. So we're starting to get information about where things are going. So store products, products categories. Looking for the orders declaration. Okay. So the failure to resolve happens, I think it's going to happen inside of this mapping. It calls make mapper config. So instead of printing out the entirety of the declarations, let's look at console.log generating kinds. And let's look at the config. Did I have config.name? I think I had access to that. It's going to go, didn't have name. Let's just dump out the entire config. Uh, I want the entire config. Can I do schema name? Do that. Get a little less information out here. Looks like at generating composite types for schema.names. Let's do that. Get even a little less information. Here we go. Generating views for order. That happens right before we get this problem. So I have done that here, and the mapper takes a config, and then the details get passed in. It says if details kind is composite type, I'm going to go in here and I'm going to do console log inside mapper details kind. Let's save that. See what this shows us. Inside mapper view. That's what I want to see. This says I know that I'm not going to deal with this because kind is not table. So I can rule that code out. And I'm also not looking at a composite type, so I can rule that code out. So this code might be doing something. And this code might be doing something. So I'm going to put some log messages in here. So say console log about to get metadata. Oh, and here, log about to generate properties. And save that. So it looks like the problem occurs in about to generate properties. Let's go look at generate properties. Yeah. So this calls generate properties. Wait, is that generate properties details selector? Wait a second. Does this line of code exist? Am I looking in the wrong place? Make composite generator selector properties equals generate properties selector. Okay, so what does generate properties do? So we know we're not dealing with composite types. So I think this is where the source and the target are getting invented. So this is generate properties. If this is a view, we need to check the source table to see if the column is nullable. So let's see what happens here. So if I do console log, um, I don't know what to call this. We are checking view column nullability, and we will look at p.source. Why not? Save that. See what we get here. Okay. That is looking plausible. It happens. Let me put a blank line in here so I can see a little bit more clearly. I'm going to put those question marks in resolve type. So what I'm seeing here is that we check for nullability. The source gets printed. We get the question mark and we say could not resolve source. And I'm going to do console log after nullable check. No, this problem is happening after the nullability check. But it's happening. And then over here we have console log get property metadata. Now this resolution issue happens after that. Because that's where resolve type gets called. This is console log after resolve type. I'm starting to understand the flow of this code. Yeah. Okay, so that happens. This makes sense. That is in resolve type is where the problem happens, that it can't resolve it. We're looking at about to generate, so we're inside generating views for orders. This is what we care about. And then we operate on each column in the view. Let's go to console log, resolving type for, let's look at B and details. So we're resolving type for price. It's really fun because the price is right there. Like it knows that it's an integer. That is p.name, p.type, and p.source. I'm going to look at those three things. I'm just going to try and peel down this information a little bit more. P.name, p.type, and p.source. And then I'll log the details are details. Save that. If I say resolving type for price, says that it is an int4 and it's from orders products price. But this is not correct. This column is from products price. So I'm kind of seeing two ways to think about what's going wrong. One is that somewhere earlier in the flow, this is being generated incorrectly. I mean, it definitely is. That this is not the schema that that table is in. So this source is incorrect. But also, it seems like that source isn't necessary. It doesn't even need to use this source because it already has the correct type information right here. I'm wondering, I wonder if I should just tell it not to resolve views. I wonder if that something is causing a problem that it's trying to resolve views and it doesn't need to. No, still can't resolve it correctly. This is a view. Columns are in there. So I think it's definitely true that this is wrong. So that's one avenue. Like this should probably be, arguably this should be fixed. Uh, but another problem is that this resolve type like might have better ways to get that information. So let me look at resolve type. We don't have references. We do have source, not a primary key. Not so worried about that. He's saying if there's a source, which there is, find the target. We're not going to find the target because the source schema is wrong. Anything that tries to look, that's trying to look in views, in tables, in materialized views, if it doesn't find it, it's going to search in the public. Uh, but that's the problem. It's not in the source is wrong and public is wrong. So how do we walk backwards and figure out what is P? Sorted P's, property sort function, details.attributes or details.columns. If it's a composite type, we're going to go attributes. Otherwise, we're going to go details.columns. So details generate properties. This calls generate properties with details. Details are passed into the mapper. The mapper was down here because we are calling schema.views. Make composite generator was created here. And is called with the kind and the instantiated config. So what is the instantiated config? Give yourself a nice buffer there. Yeah, table schema should be store because it's store.products. So the instantiated, oh, that's funny. I'm logging out too much information. And so I think I can't scroll back far enough. Yeah. So let's go to, what was I in? Resolve type. Was I make composite generator or generate properties? Yeah, these details are too big. Okay, the instantiated configuration. So instantiated configuration.schema.orders.views. So that gives us a view, and I want to look at the columns. And if we look at the columns, all right, what did I do wrong there? Let's do, I'm just going to do JSON stringify. I want to see the whole object. I want to be nicely formatted. right there in columns. There we go. So this column definition has the type information right in it, but then it also has a source. If we go down to, like, these columns are correctly defined as being from the orders, line items, quantity. If I go down to title, that's where the source is wrong. So whatever is generating this data is incorrectly finding the schema for the source for columns in a view. So where does instantiated config schemas come from? Schemas comes from extract PG schema. All right. Extract schema pulls out views. Extract view is a function. Here we go. What are you doing? The source calls resolve source. Unresolved columns. I'm going to look a little bit at this in the database and kind of see what information is this dealing with. So let's do select star from information schema. What are they doing? Dot views, where table schema equals store and table name equals order products. I get nothing there. Trying to see where it is orders, and table name is order products. So that's one of the things that they're doing. I'll look at this unresolved columns bit on extract view and extract PG schema. So this is, I mean, this has nothing to do with payments now. Uh, but my flaw as an engineer is that if there's something that's not working the way I think it should work, I really have a hard time stopping myself from getting to the bottom of things, uh, and just moving along with it. But I'm so invested right now. I'm just deeply emotionally invested in getting to the bottom of this one. I can sense that we're on the hunt. Uh, but I need to open node modules, extract PG schema. What file were we in? We are in extract view. Yeah, it's definitely. I think this is like a valuable form of debugging. Like, really have to try and like figure out what's going on in the things that you are using. It's like when the encapsulation breaks, right? There's all this stuff has been encapsulation has been encapsulated. I just run a script and I get all these types built, and then it breaks, and I'm like, I've got to go diving deep within. Uh, okay, so here we have the unresolved columns, resolve source. Resolve, what is this function called? It's also like, so, and this is what happens when you write this TypeScript and you get it compiled into JavaScript, and it just looks like a total mess. So you have to like be looking at, what does the source code really look like? Resolve source, columns. Let's look at columns. All right, I am logging out more stuff than I want to log out. And I stop logging the instantiated config. Let's get columns.source. Where did I log that? Yeah, so we'll do columns.map, column source. I'm looking for something that doesn't look right. What's going on here? This logging output seems really off. Panel running in parallel. It kind of looks like it because like these log messages are just a mess. So look for canal documentation. Definitely appears to be running in parallel. So stop logging that. Yeah, where am I logging schemas? Here. I'm going to stop logging schemas. I'm going to do process standard out right. This might be a little more clear what's going on. Let's do columns. We call this resolved columns. JSON stringify. Okay, that's a little better. Yeah, this is showing us in this view resolution, this is mismatching the schema and the table because the products table is in the store schema. So the problem is not in Canal. The problem is in extract PG schema. And I want to look at, before we do this, what does unresolved columns look like? That broke everything. Why is it an array of null? Okay, that's a little better. But does not, I don't see that output anywhere. Go back to console log, console log. So wildly confused. This was unresolved columns. Appears to be not showing me anything. And I think it might be this progress bar thing is messing up with the console output. Who is doing this progress bar? And can I get it to stop for a second? So let's see, extract PG schema. Are you the one who's doing this ETA? Something like progress. Extract schema options on progress. So yeah, Cannel, I think, is doing something with progress. Search for on progress. Yes, the CLI is doing a progress bar on process database with a progress function. Can I get it to not show the progress bar? Process database takes in a progress option and filters that in. So I can just say, let's not show progress for a minute. Let's go back in here. And I'm just going to say, no progress today. Do Cannel Y. My terminal is being a little strange right now. Make a new one. There. So all the unresolved columns are coming through as a null. So what is the source mapping? Source mapping definitely has the wrong tables. So source mapping is defined from parse view definition. We are zeroing in Parse view definition. All right, let's look at parse view definition. This view reference might be the thing. I'm going to look at the view reference. Oh, am I looking at the wrong parse view definition? Got extract view, parse view definition. Source kinds parse view definition. View reference. Okay, I was looking in the wrong file. Here we are, view reference. Let's look at view reference. Yeah, these view references are being built incorrectly. So the schema is source schema or default schema. Is it assumes that the source schema is the first from table dot schema name. So this system doesn't understand that we can join across schemas. And so what is extra wild to me is that as far as I can tell, it doesn't even need to be doing any of this because elsewhere, I'm not logging it anymore. Yeah, it has. Like there's this whole system that this library is doing, trying to figure out what is the correct type for this thing. Whereas like elsewhere, it has the correct type right there. Something else has figured out that this is an int4, but because it's a view, it's trying to do its own stuff to parse it out. This is interesting to me. Kind of feeling close to being able to put this down. Like I think I have found the source of the problem, and I understand trying to understand what's going on. Like why, like I understand how it's gone wrong. I don't understand why it's like why this, I don't know why this developer built this in this way. It seems like there are other ways to get this information. I guess kind of want to look at the, yeah, and so there'd be multiple ways to fix it. I'm just kind of curious. If you just select star from information schema dot columns, what do we get? And then let's say where table schema equals orders and table name equals order products. Like, as far as I can tell, almost the entirety of what this system is doing is unnecessary because this query right here tells me everything. It's like I don't know what I don't understand what's going on. I just want to look at this. So got column name. We had default. We've got it. We've got the data type. Let me see if there's something that tells us. So we don't have the information about foreign key constraints here. What else is an information schema? We've got what happens if I do select star from information schema columns where table schema is orders and table name equals line item. What do I get there? So there I get these columns. It's like the downside so far is that nothing in this tells me whether these are a foreign key. So I wouldn't be able to get that yet. And what if I want to look at orders order? In orders orders, this tells me I have a user-defined type. I could do select star from information schema dot types, user defined types. User mapping options. I don't know where my enum is defined. I wonder if that is in PG enum. So trying to see like how key column usage. We got foreign key constraints here. I wonder if I just search like Postgres query for foreign key constraints. How to list all foreign keys in a PostgreSQL database. Must be. Look, there's got to be a simpler query than this. From PG constraint, where constraint type is F. Let's look at PG constraint. Is in PG catalog. So select star from PG catalog dot PG constraint. Where con type equals F. So this gets us all of our foreign key constraints. The issue is this doesn't tell us our table name. So how are they getting the tables? Select con rel ID reg class as table name. So we're going to select, I'm going to get more specific here. Con name, constraint name. So that's interesting. Here these table names are joined up together. Can I get, what's the connection rel ID in Postgres? Table this constraint is on. Relation ID, Postgres, constraint relation ID, table and schema. Object identifier types. Reg class gives us our relation name. Reg namespace is table from conrel ID as namespace from. What is that gonna be? Can I join these together? No. Do That's interesting, is that these are, I wonder if there's something in the public schema, would it show that? Yeah, so this is, so the foreign keys are a little weird. PG get constraint def. It gets us the definition. Maybe someone's like built a wild query that'll just get the whole thing. Yeah, and these don't split the table in the schema. Mm. All right, so spent more than enough time digging into this. Uh, this is really, what a frustrating thing. I'm gonna check generate type definitions from Postgres. Like maybe there's another tool that does this. Here's something. PG to TS. PG to TS. Generate some schemas. Look at schema TS. Hasn't been updated in many years, so that might be a bad sign. This hasn't been updated in a year. PG schema CLI, generate type definitions. It's interesting. What is at databases.org? This is a database wrapping library. This may be curious to know. Not very widely used. I have heard of called Keasley. So let's see. Generate type definitions for PostgreSQL database. We had PG to TS was an option. Canel was an option. Introspect Postgres. Generate TypeScript. Okay, this is a tool, Supabase. I'm not using the full Supabase product. This is like a system that wraps your database, but I might be able to use their tooling. And Supabase, there's an advantage to possibly using their tooling, is that they are a actual product, and so they have funding, they have customers, they have an incentive to maintain this tool. Whereas the other things I've been looking at are just sort of community projects. They're not bad, but sometimes money is very helpful. So what npx Supabase gen types TypeScript. So let's see what happens if I do that. Okay. npx Supabase gen types TypeScript. You have to install. Oh, I typed that wrong. So let's see what happens if we do this. We got to give it a DB URL. Let me get my DB URL out of here. Why are you trying to connect to Docker? If I say generate TypeScript types, I want to say local and DB URL. I see. Local is not meaning here. Well, I don't know that this tool is going to work for me. Try schema store. No. I do have Docker available on my computer. I'm just going to see what happens if I install Docker. Docker is a system for running virtualized systems. Supabase does, so I'm just seeing that question. Supabase does a lot more. It just happens to have as one of its features uh, this. Supabase is pretty cool. It is, where is that terminal? Uh, Supabase wraps your entire database and helps you build a lot of things around it. Okay, Docker is still loading. So it's like you get Supabase like generates a lot of your backend for you. Like you have a database, and Supabase looks at your database and builds out a whole backend. Uh, it is definitely super cool. Uh, yeah. And also, like it builds in things like authentication. It does a lot. It's a very impressive bit of tech. Why is Docker taking so long? Yeah, it just sort of like it says, hey, this is what your database looks like. You have these tables. You're going to want to be able to insert data, delete data. It has a way to configure the authentication, the authorization. It's a pretty complete package. Docker not starting well, so I'm gonna give up on Docker right now. Yeah, and so because of that, as part of its operation, Supabase needs to be able to inspect your database and generate types. Uh, okay, well, this is frustrating. Uh, yeah, doing a lot of stuff. I So because there's no actual pressure to sell a product, and I am again thoroughly invested but frustrated that the that this type generation thing is not working. I'm gonna like really just lean into my least productive tendencies. I'm gonna generate my own types. Uh, like I looked at this stuff and I'm like, I think I can generate type definitions from this. So I'm gonna do it. So I'm gonna get rid of that. I'm gonna get rid of the CANL file, and I'm going to make my own script to generate types. So I'm going to make a new file, generate types, TypeScript, and this is going to need to get the database. So we will exec query, and we will I think the first thing I'm going to do is I want to get the schemas out of the database. So let's see, we get Postgres query to get all schemas. How to list all the schemas in Postgres. Select schema name from information schema dot schemata. So let's see what this gets us. Okay, and I want to skip over the built-in one. So I'm going to say where schema name not in, let's say PG toast. I don't want that one, but I need to say something. I think I need to wrap these in parentheses. Yeah, so it's not in PG toast, PG catalog, or information schema. That gets me down to just the schema that are not part, because these are like built-in stuff that uh, I shouldn't be messing around with. So let's do um, rows equals schemas. The schemata, but I'm going to do schemas. We're going to select schema name from this, where schema name not in these schemas to skip. Make a const main equals async. And then I want to console log schemas. So I'm going to go over here and I'm going to run npx ts node dev source generate types, and I want to do respawn, and this is going to watch this, and every time that I save this file, run it. And so if I need to call main, actually invoke this. Okay, so this has got me my schema names. I'd like to keep this list of schema to skip outside, so I'm going to see if I can do this. I'm going to say const skip schemas equals that, and can I do not in $1 skip schemas? To do like that. Hmm. I have to do, can I do an array $1? For node PG not in array. I'd like to do this. Use where ID equals any that. I want to do not in. $1 as a string array. Text array. No, it doesn't like that. No, it doesn't like that. So just going to go ahead and keep the skip schemas out there. That's should be all right. I've got my schemas. And then I want to get rows for all of these. Well, that's interesting. Table name from in. Well, I don't want exactly that. But I am curious to see what we get here. So we'll console log tables. Yeah, because I don't have anything in that. So we're going to do not in. I'm going to type that out for me. There we get tables. Like table name, table schema. But I want to do where table schema in these schema. That's where I would want to do like $1 and pass in my schemas. But this doesn't like using these positional arguments. Maybe I can do this one where it equals table schema equals any $1. And this needs to be an array. There we go. We've got all of our tables from there. And so this is good because I can expand the skip tables to be like, maybe I don't want to put orders in here. And then I can filter that out. So I can do the inverse here. So I can see is not equal to any $1 and pass in I need this list. So it's not equal to any of those. And it's not one of these. Ah, that was a little wrong. So what did I mess up there? getting that's annoying that I can't do that. So I can say where not in $1. And that gives me everything. Say in $1. It's interesting. So why Postgres query not in array? Do where not? I do where in, where I saw, maybe I was just misreading. Yeah, I think I was just misreading. So frustrating. So I shouldn't do this. We can do where schema not in. I'm going to do const skip schema equals that. You can do we're not in skip schema join with comma. And I need to do trouble is I need to wrap these. I need to like quote these, which is slightly annoying. But that'll work. I don't like having to quote these like that. I might as well just write them in SQL. But let's keep it going for a second. So I've got my tables, and I want to get the columns. So I think I'm going to just map over each of the tables. So we'll do uh, for const table of tables. And I want to, so I had a query over here that got me the columns. Yeah. So let's do const columns will be select from here like this. And then we'll do table.columns equals columns. And then let's log our tables out. I'm going to do stringify these. You can see the whole thing. So here I'm starting to get my table name and my table schema, data type, and the column name. And then let's go with is nullable. I also want to get the is nullable. So now I know if they're nullable or not. I'm just going to get no or yes. I can deal with that later. So I know if they're nullable. And now I also want to get the views. So let's do const rows is views equals exec query select from views. We get the schema names. Move this down here. And we'll do for const view of views. We'll pull the column for the views. Going to be similar to that code. Let's log the views as well. So now I've got the correct data types for everything. So like part of me wants to know where is the why is that other system so complex when I've got like 80% of what it did I already have right here. Now I'm not tracking foreign keys, but I probably could. I want to see, can I get foreign keys out of here? So let's say, I want to say get foreign keys. So const row foreign keys. Does Copilot know enough to generate a query to get all the foreign keys? Quite possibly. Get all the foreign keys. Console.log foreign keys. I'm going to omit these logs here. Let's do this at the bottom because I'm logging all the queries as we go. So the foreign keys, you can get the foreign keys. That works just fine. What about get primary keys? So these queries are pretty big, and I'm glad Copilot knows how to get them. Probably if I wasn't using Copilot, I would just go and copy and paste these from somewhere that has an example of how to do this. So I would enjoy knowing more about all the details of this, but that's like one layer down deeper than how I understand these systems. So we've got our foreign keys. Let's look at the primary keys. Got the primary keys. So that's fun. I don't know if I'm going to use the primary keys and the foreign keys, but I can get them. What I do know, I do want to reorganize this so that I am looking at the schemas and the tables together. So here I've got my schemas that have a schema name. So I want to construct my const schema is an object. And then I want to do for table of tables, let's, we're going to do this with views as well. So this Copilot kind of knew what I want to do is I want to collapse all this data into one big schema object. And let's look at that. Okay, so I have to tell TS Node Dev that I'm okay with type errors for a moment. I'm going to tell it to transfile only. Don't type check. I see these red squiggles. I know that they should be typed, but I'm not going to do it right now. So let's look at that. So this is not quite right. I don't want just a single flat schema. I want the schemas. So let's say I want to um, create single hierarchical object containing, yeah, for all schemas. Is that enough? Yeah, awesome. This is using a cool reducer, finds all of the views and the tables. I think though, I don't, this is doing tables as an array, but I don't want that. I want single hierarchical view for all schemas with tables and views nested inside each schema as an object where the table slash view name is the key. And let's see if this does that a little better. No, it's still trying to turn them into an array. So I'm gonna have to do this by hand. Sorry, Copilot. I didn't know how to describe this well enough for you. Uh, so let's do uh, const schema is an object. And then for table of tables, we're going to do schema table dot, what do I get out of here? I get table schema or equals an object. And then the table name is going to be just the table. And that's what I want. So I get store products, you get that thing. And I'm going to do the same thing with views, except for views, we called it Oh, it's still called a table schema. So this will be pretty much identical. So there I've got my schema divided up by schema table, and then I get my columns inside of that. So having some TypeScript complaints, so let's get that fixed up. One, so or equals is saying, yeah, it's in JavaScript too. So it says, if this value doesn't exist yet, assign it. But if it does exist, leave it in place. If I didn't do that, this would break because there's no value there. So it's like the first time that you see this, initialize a blank object. Every other time, add to that object. So I don't have types here. So I'm going to define some types for this. So I want to define a type for this query. This is going to be, type will be schemas. And we'll do a schema name as a string. So we're going to say this is going to return schemas. And then we'll do type tables. That, good, you're figuring that out. And these actually should be interfaces because they're more like objects. And this is going to return tables. And then we want columns. Column name, data type, and is nullable, which is yes or no, which is hilarious. So this is going to return a columns. Okay, so then a tables has a columns, which is a columns array. And view, this returns a columns. And views, I'm not going to differentiate. I'm going to say that views returns a tables. And then schema is a record of string to record of string to tables. And so this type definition matches this object. So now if I look at this, I can do schema. I don't know what the names are. But this is good. I'm getting the data out. And now I want to generate the TypeScript. So instead of logging that out, I am going to go from this data to type definitions. So I think I'm just going to iterate over and print stuff out for a little bit. So let's do so for const schema of schema, and I'm going to rename, I'm going to go with the cute name that Postgres used. This is the schemata, plural of schema. So for schema of schemata, what did I do wrong here? Yes, we'll do object.values schemata. It's going to do name and schema of object.entries schemata. Well, that's wild. Uh, what do you think you're doing here? Okay, file shows the path, gives us the type. Yeah, I don't know what I don't know what this word schemata is. Uh, yeah, let's log that file. This is like getting close to halfway there. Uh, so what I want to go is these table names, and I want to turn these into like nice camel cased names. So I'm going to create a function to convert snake case to camel case. This is going to be to Pascal case. Snake to Pascal. We're going to replace uppercasing and get that. And so I want this table name to be Pascal case, which is, oh, it's not uppercasing the first letter. They're both correct. That's good to know. What is Pascal case? Yeah, I'm not getting the first letter. So I'm going to look for convert snake case to Pascal case in JavaScript. Go. I see. So we've got to do the first letter. So I'm going to grab these functions. This is a string. That is a string. Make TypeScript happy. So now I'm generating some code here. We got order products. Uh, so let's get some space between these. I see. So that's giving us the name here is the schema name. So I'm going to rename that so it's a little clearer. Schema name. And instead of doing nullable as or null, I'm going to make these optional. And so if you're optional, we're going to do nullable here. And then we got export. And I want to get my indentation a little cleaner. And then close off a little cleaner. And I'll put a blank line in between them. So now we're getting export interface order products. Now it looks like everything is coming through as nullable, which seems wrong. Okay, so this thinks that everything in the view is nullable. So this might be why there's a little bit more going on in that thing. Is it's got to figure out, are these really nullable? They really shouldn't all be nullable. Got line items looks good. User looks good. A couple things here is though the types here are not correct. So I've got to go get some way to convert this data type into the actual desired type. So I'm going to make a little function here, which will be const pg type to TypeScript type. So I'll take in a pg type, I'll switch. We've got all these types that are really number types. And this is nice that Copilot knows about all these things. We've got all these types. This might be more types than really makes sense to make this. Some of these should probably not be string. But I'm just going to go with it for a moment. So many types in Postgres. I'm certainly not going to use. I think this just sort of got a little out of there. I don't use all these types. I'm going to say return string if you get those. Boolean is Boolean. Don't know about date types yet. That's starting to get a little better. Why does big int? Oh yes, and so now instead of just putting down the data type, I want to get the PG type to TypeScript type. And now that's looking even more like TypeScript types. We've got these undefined, which is a little better. I'm going to say that the default is return unknown. Now I've got some unknown types in here. I know that I wanted to say case if we get a byte array, that comes through as a buffer. So we're getting closer. There's two things that I don't like about this still. One is that on the view, it thinks that all of these are maybe nullable. Whereas I would like whether or not these are nullable to be determined by the actual table that the view is selecting from. And that did seem to be the thing that the other tool had trouble with. But I still think we might be able to reduce the complexity of how we get that answer, given how, like, we've got 90% of the way there with very little code. And so I think I I think that we can get the rest of the way there without so much code. The other thing that I don't like here is that I don't have the enumerable. So on the order, the status is unknown. But in the database, we actually do know that type. So let's see if Copilot can help us generate. So get all user defined enums. And let's see, can Copilot help us select that? And let's console log enums. Oh, didn't want to get rid of that. And then I will do, just going to exit right away. I can just see that output. Invalid input syntax for type OID public. See if it is something to do with that. Okay. So this gets me the enums. There's something about type space and type namespace. Does not like. I'm going to go into Postico. And let's see what this looks like. And let's get t.type namespace. Let's just see all this. So those are numeric. Can I get how do we get the I'm doing on battery here? Ah, one of these is out of battery. Question is, if I take that out to charge it, can you still hear me? Looks like, oh, microphone is still coming through something. Okay, so I want to get Postgres query all user defined enums and values. Look up all enum types and values in Postgres. That's okay. I think I don't need, if we look at what we get out of here, it doesn't seem strictly necessary to, I'm not getting any data that I don't want here, but I do want to group by the enum name. And then we'll do array ag label. Almost there. I'm just getting little sounds in my head that's saying battery is low. But this syntax is not exactly what I want. Can I do JSON ag? There we go. So I get the enum name and the values that it can have. So then I want to convert my enums into some kind of an object. So I'm going to say this is an enum list. And then I'm going to say const enums. I'm going to reduce that. And does this kind of know what I want? Yes, so order status is either open, closed, or canceled. Good enough for me. So then I'll go down here in generating my schema, and we will emit TypeScript enums. So we'll iterate over those, export the name and the values. And we'll log the enum type. What am I missing? Missing that. So that'll get me enum order status. And a trick here is that the enum values, this is not going to be valid. But I think I can turn them into, if I do JSON stringify on those values. Almost. I'm going to have to do them individually. So if I do map value JSON stringify the value, I'd be okay with saying that that's an any. Then I get enum order status equals open, closed, or canceled. But I think instead of doing a TypeScript enum, I'm going to do type equals, and then I'm going to join them with pipe characters. So I get order status is open, closed, or canceled as the, and then I don't need those equals. I just need this. We're going to say order status is open, closed, or canceled. And I like that. I'm just going to log blank line. And then down here, for this unknown, for the PG type to TypeScript type, let's see. I want to see what the actual type was. Came through. So this says we had user defined. So let's look at our columns. I'll look at this raw data. And so we get user defined. So let's look at how do we get more information about what does user defined mean? This is where table name is orders and table schema is orders. That's user defined. So what other information do we have here? Data type is user defined. User defined type schema, user defined type name. That's interesting. So these types can actually do the data type we can select as UDT schema and UDT name. And then we're going to get this. I'm going to go change my column selection to so my columns is now instead of a data type, we're going to get UDT schema and UDT name. And then we'll go to these and we'll update these to be UDT schema, UDT name. We'll do that for views. Excuse me. Now these all turn into unknown because we need to update. We're not passing in data type anymore. We're going to pass in column dot UDT schema, UDT name. Let me make these a little more readable. And now all of these need to be prefixed with the PG catalog dot int8, PG catalog int4. So let's, I want to see what are all the types. So let's do select star from PG catalog. No. Select star from PG catalog dot columns. How do we get columns? Information schema dot columns. What does PG catalog have? PG type. Here we go. Here's all the PG types. There are a lot of types. I'm not going to deal with all of them. but I will start with some of the simpler ones. Just looking at what information we have here. So we have PG catalog, int2, int4, and int8. Those are all going to be return number. And then, is there a decimal? Is there a float? You can't filter on the free version. I don't have anything like that yet, so we have pgcatalog.text I'm using. That'll return a string. pgcatalog.boolean will be boolean. pgcatalog.bytearray will be buffer. Otherwise, we're unknown. So that gets us all of our types back. And then I want to get order status. So let's look at what PG types we're getting through here. Orders.order status. So I'm going to say if PG type starts with PG catalog, then I'm going to do this. That keeps things happy. Otherwise, we're going to say the schema and the name split on the dot. And I pulled out my enums, but it turns out I think I do want, when I did my getting the user defined enums, I didn't get the table. And I think I do want the table. What other information could I have gotten from here? Get star. So you get the enum name, the type name, okay, so that's getting us the value. But can I go from PG type to schema name? So if I do Postgres get schema name for PG type, PG namespace. So that's the type namespace. What can I get here? That was the enum label. Let's get enum label back in there. And then t.type namespace. Like, is this thing that I can do reg class on? No. So how do I go from OID to schema? So Postgres OID to schema name. How do I get schema of a table if I have the OID? Need to join PG namespace to PG class. Join like that. Join PG class. T dot type namespace equals PG class dot rel namespace, and they do namespace dot namespace here. Enum label types namespace, but I want to get PG class star. Not seeing anything that looks like the table name. NSP name? No. And PG namespace. I'm going to join PG namespace. Select star from PG namespace to see what's in there. Equals PG namespace dot OID. And I want PG namespace dot NSP name as schema. And there you go. I get the schema out. That's I want to bring part of this into that query. So let's add join PG namespace on T type namespace equals the object ID. And then let's get the PG namespace as schema. Let's see what that gets us here. That gets us everything blows up. So I have to group by enum name and schema to add that to the group by. That is looking good. So now the enums really need to go into my big schema definition here. Instead of doing it like this, I'm going to put my enums. I don't have to call this an enums list anymore. I can just call this an enums. You can say similar thing here for const enum of enums, schemata enum schema that. Sign it. I need to go. What if I missed here? enum values. There you go. Hold off on emitting the TypeScript enums for a second. I want to get those into here. Enum is a reserved keyword, so I can't use it like that. TypeScript also defines its own kind of enum, so I've got to give that its own name. Okay. Because this isn't a tables, I have to go and modify my schemata is going to be an object which is going to have tables is that record, and enum, I'm going to say types is a record of string to type, which doesn't exist yet. I would say user defined type. That's really, I don't have any other types other than enums. So I'm going to go with, just make that an enums. And so I've got to have this is going to be defined here. So this will query out types of enums. We'll say interface enums is enum name, schema, and enum value. And now generate types is unhappy there. So because I'm not constructing this correctly now. So this is going to be tables starts out empty, and types, I'm going to rename that to be enums. Enums, while if I don't do it like that, I'm going to say you start out making that an object like that. So instead of defaulting to empty, we're always going to default to something with both of these. We can say dot tables, or dot enums. So where is this complaining now? Am I logging? I don't want to log out. Tables or views here. Generate types 196. Yeah, so instead of this being tables, we want to do object.entry schema.tables. And there we go. So we get our interfaces there. And you got types. This is going to be specifically the table types. I want to get the const enum types equals object entry schema.enums. We'll map over them. We'll generate the enum type. We'll export enum values. those up. Why don't you like this? Line 198. Not plural there. There we go. So this generates stuff. And then we output the table types prefixed by the enum types. Let's give that blank line. Now in the orders we get order status is open, closed, or canceled. And we're still getting undefined here. So let's go here. So we have schema and name, orders, order status. So we need to, it's like the dumbest thing would be just return, well, that'd be interesting. That doesn't quite work because we got orders, order status is not correct. But if we just did the name like that, it's going to work for our purposes for a second. It's going to be this would cause a problem if we tried to reference schema enums across schemas. So I'll say this to do this will break if we reference enums across schema. Schemata. But this is at a basic level pretty much it. There's a lot less code. It does everything that I want it to do. And I probably spent about as much time trying to figure out what was broken about the other thing as doing this. I don't love this code 100%. It's a little messy. Also, it's not yet writing out to files. But we can deal with that in a second. So I've got here. So I'm going to say const file path equals. I'm just going to go with source types schema name and const type definition equals enum types table types. I can make that simpler. I can say enum types table types join, put two blank lines between them, and then we will log file path and log type definitions. That gives me what I want. So I'll have this. What are we doing here? We are in a for loop here. I'm going to say interface type defs is say type definitions is a record. Now, so type definition is a file path, is a string, and type, let's say source, is a string. And then type definitions is going to be type definition list. Say const definitions is an array of type definitions. Start that out as an empty array. And then once we get here, we will do definitions push. It's an array of type definitions. And then we can look at definitions. And that's showing us what we want to see here. So I'm going to make a quick test for this because I like the output. I want to make some modifications to the structure of this source code. It's a little messy. So I'll make a generate types.test.ts. I'll get out of here and I'll go and I'll look at my test runner. And I'll say describe generate types. It could generate types. True is true. But I want to, let's see what we've got here. So at the end of generate types, I'm going to return definitions. And I'm just going to say generate types instead of main. This is now a function called generate types. Instead of calling it, I'm going to export it. And then we'll say this should be async. And we'll say generate types, which we'll import from there. We'll await. I want to do some things here. I want to so I've got this skip schema thing. But maybe I actually do want to explicitly say which schema. To use. So for a moment, I'm going to pop this out of here. And we're going to say this is going to take in schema, which is a schema. Rename this. I don't know. I'm annoyed by this ambiguity. We're going to say schemas is schemas. So and it's going to, let's go to generate types. And if we call generate types with empty array, let's say const schemas, which is schemas. I have to go over here and I have to export this. empty array. Well, I think that if we call this with nothing, it'll simplify. So schemas here, I'm just going to simplify this to be a string array of schemas, and we'll call this schema names. And so everywhere that I do this, I can replace this with schema names. So now if I call generate types with an empty array, I can expect that to equal an empty array. Let's parenthesis there. Oh, that's funny. It got the enum anyway. So I just learned something about my system is that it's going to pull in enums even if you tell it not to deal with that schema. So let's go to where I am getting all of the enums. Where am I doing that? Enums here, where E type category is E, and where schema equals any of $1, where $1 is schema names. I shouldn't do two wheres, I should do an and. Let's see, do we still hear me? Are we still getting sound? Okay, I think I just swapped over to an entirely different microphone without realizing it. Schema equals any column schema. Oh, so this was, as I renamed it on the outset, but I need to say where PG namespace equals that. Okay, so if you tell schema generator to generate schema, to generate types for no schemas, you will get empty. And so I'm going to update my, I'm going to say before each, I'm going to make a schema just to test with. So I will say async exec query SQL drop schema if exists, test cascade, create schema test. And then we'll create table, I don't mind calling it users. For the test. And we'll say, so we'll describe with no schemas requested. Should generate no types. We'll say describe with schema requested. It should generate types for that schema. So I'll say const types equals await generate types test. Expect types to equal schema test.
is not quite what we're expecting here, but that's okay. We can do to match inline snapshot. So snapshotting is a wonderful technique where you tell the test runner that I don't know exactly what I want this to match. Uh, and so it says, cool, I'm just going to run this, and then I'm going to go and edit your file and fill in exactly what that was. So then if you ever go and do something that changes it, then you get a warning that says like, hey, that doesn't match. So I'm just kind of like, I think I like what I had there now. I just want to get the snapshot. Uh, so this makes sense to me. Now in my schema, I'm going to have a type. So let's create type test status as enum. No, this is specific to vtest. So you can get this in JavaScript as well. It's the test runner knows how to do this. So I made a change there. I'm going to see what changed. So my source added export type status equals open or closed. And I was close. I needed those. Now I don't like that I have these escapes. Why is that? So we're doing JSON stringify. So let's see. If I just do the value, I get that. So I don't know if these are always going to be strings, but for now, I'm going to go ahead and pretend like they are always going to be strings. So that will satisfy my test. No, I've still got those little slashes there. So maybe I'm overthinking this and it's not really a problem. I'm just not aware of what's going on here. So I'm going to delete this snapshot and get it to regenerate the snapshot. I might have to, when I get this written out to a file, I might have to come back and solve that problem. So the other thing that I don't like here is that I have all this extra space here, and I'd kind of like that to get flush left, but I'm also gonna, that's not gonna cause huge problems. But I do want to use my schema. I want to use my enum in here. So we'll do status is a test status, not null, default open. And so that updates this to have a status status. on a nullable column, so let's go with favorite color, which will be a text. And that gives us a favorite color string, but we get the question mark there. So I'm gonna make sure that I do my test with multiple schemas. So let's do drop schema if exists test2, create test2. Let's call this like posts. They've got an ID, they've got a title, got body. Let's create an author ID. Int not null references test user ID. And make another test. It describe with multiple schemas requested. It should generate the types for those schemas. Then I'm going to delete the snapshot. So this looks like what I want. Just, I guess that shouldn't be null, it's fine. So that is my types being generated. The one thing that I'm pretty sure is going to break, so I might as well add it now while I have the test, is I want to test doing oh, I should do a view, shouldn't I? So I'm going to make a third schema. Let's do drop schema if exists test3. I'm going to do create view. This is going to be posts with authors as. Got to do select post.id, author ID, title, author name, joining. Yeah. So now I am doing cross schema joins. And cross schema joins was the problem that got us into this mess anyway. So I want to do one other thing is I want to make sure let's also get the status of the user. So let's do u.status as author status. Let's really make problems. So let's describe cross schema views. It should generate types for all those schemas. Generate test2 and test3. Let's look at what we get for the snapshot. Didn't get anything for test3. Because I didn't put this in the test3 schema. So all of the, okay, so here we've got this problem is that we think that all of these are optional fields. So we want to solve that, and we want to solve that now. This type is really coming from this file. So you have to do some sort of cross schema import. So what I want to see is something like import star as test from /test, and then this will be test.status. So I'd like to see that change, and then that none of these are optional columns. These are changes that need to happen. So let's go figuring. So for a moment, I'm going to skip cross schema views because everything else works fine. And I wanted to do a little refactoring. So this stuff to pull out the foreign keys and the primary keys, I don't need that right now. I'll make a generate types.notes.markdown file, stash those in there because I'm not going to use them yet. And then the first thing that felt kind of similar to me was the way that I'm getting tables and views is almost identical. Except one selects from information schema, information schema.tables, and one goes from information schema.views. So I want to get some function to help me with that. So I'm going to say const get relation, uh, which is going to work for both table and view. A table is a relation and a view can be like a relation. So I'm going to grab tables and move this over here. And so instead of rows, we're going to call this relation. And we'll call this table name as relation name, table schema as relation schema. And then this is a relations. This is the one that's relation. And now tables turns into relations, and we're giving it a relation name and a relation schema. So we've got to use this instead. Still gets a columns, but we will return relations. So then we can do, why did I get rid of tables? So we'll say const tables. No. Should be back now. Yeah, I'm not sure what happened. Dropped out, definitely. Uh, so I am going to have to eventually change this line because I'm selecting from tables. And for views, we're selecting from views. We're going to have to make a change there. Uh, but we're not quite there yet. What did I just change? I changed tables equals and then save. Ah, yeah, I've got to change all of these to relation schema. So let's go take everything that says table schema. I can't do it everywhere. But yeah, I got to change this to did I just break? So let's do console log tables. Users test columns. I'm actually going to change this since I'm doing this since I'm in here. I'm just going to return as name, as schema, relation name, relation schema. So these have a name, they have a schema, they have a column. And then I want to select from a relation kind, which is either going to be views, tables, or views. So we'll do from information schema dot dump in relation kind. So I've got to do get tables is tables. And then const views will be the same, but for views. So we can get rid of that. And then here, this is going to want us to rename this to schema, schema, name, do the same here. Schema name. So we've got an unexpected new line. So what's going on here? So this says, oh, we're getting nothing. We wanted to get all this. We didn't get that. Got happy types. Let's see what we are running. We should be getting stuff. Let's see. Get relations. Let's say console.log relations. Let's do relation kind and schema names. Okay, we got tables. Then we're skipping the views tests for now. So that should be fine. Should be seeing console log schemata throw new error. Just want to stop early and see what I printed out there. So that should be, let's do stringify this so we see the full object. Ah, we are not getting the columns coming through. So what did I break here? So we're doing select column name for, oh, I think I've got these backwards. Let's see about that. Here we go. Now I've got columns coming through. So I just got this order flip-flopped somewhere when I was changing that. Okay, now we're back to where we were before. So I can get all the relations for a set of schema, which seems good. We can get all the enums. I'm going to pull that out. So I'll say get enums. That way that extracted that confused me. So I'm going to do, go up here. We'll do const get enums equals async schema names, and we'll return the enums at the end. And this is going to return an enums array. So we'll do const enums equals await get enums schema names. So I think this part here, because I'm treating these just like tables, so I'm going to convert this to relations and say that relations equals an array And I'm going to flatten these together. And then we'll do for const relation of, keep that table for const table of relations. And I'll rename this to be relation of relations. And then, because I'm still calling this table here, I'm going to go here and say this is now just the general relations, and that renamed everything here. Okay, this is all still safe. This type is bothering me to have it in line here. So I'm going to say this is a schemata, and I'll move that type up here. I think I can make this, because it's starting to look super wild. If I do interface schemata has a key, it's going to be schema is a string, which looks like this object, which has relations, which is string of record to relation, and enums, which is string of record of string to enums. I think that's a little more readable. We've got get enums extracted, get relations extracted, kind of flattening this up a little bit. Got PG type to TypeScript type. This generation code is still such a mess, so let's tackle that next. So I'm going to, how am I going to tackle this? Let's start with enum types. So let's say for const enum name and enum values of object entry schema enums. So messy. I say that enum name is snake to Pascal enum. But I guess we'll go call this const Pascal case name is that. And then we'll say enum source equals export type Pascal case name equals, what do we got here? Not, okay, I've got some. And then I want const enum values is, so we'll do map the values, stringify them, join them. We'll say values source is that, and we'll say enum source is that. I see. So I don't mind doing a map here. So we'll say const enum types sources equals that dot map we get enum name and enum values. We get it like that. So this reads a little bit better to me, but it's broken. So I change this to enum type sources. Change this to be on one line now. I've got that string quoting around it. Instead of stringifying, let's call this PG enum type to TypeScript type. So we'll do const PG enum type to TypeScript type. We have unknown. It's not a string. We don't know what to do with it. That's fine. We'll say if PG type, if type of PG type equals string, then we'll return quoted string PG type. So if we ever have to deal with different types, we can deal with them in there. And so we can do a simpler map here. We can just map over PG type to TypeScript type. Then expect we should see open or closed. Why is that? Ah, here, because we're mapping, now we do a return. Type status is open or closed. Let's see, it still escaped because there's a string wrapping it. But we're not closing that because we still have new lines here. And then this is also broken here. And here. don't have these awful escape marks anymore. So this looks more like what I want to have happen. So that solved a problem that we had. No, so I'm just losing my mind here. Yeah, so we expected that, but received it with these escape marks. So we need to keep those in our test. Where is this? Should generate types for those schemas 1. And this is in with a schema requested. All right, losing my mind here. What does it think the snapshot is right now? No, we still have that. So confusing. It's like string escaping is sometimes very, I have no idea what's going on with string escaping like that. Got the JSON stringify. We are wrapping it in strings. All right, yeah, double escapes. Don't know where I'm looking at, but I like this a little bit better. So Gordon's interface, stringing those together. I think the main thing that I want to solve for now is that this one, the cross schema views, are all broken. Yeah, so let's say this is a problem. We should be able to correctly determine that none of these are optional. So let's see what we're doing here. We are selecting a bunch of this stuff. Where your table schema is, I gotta switch to shopping cart test. We've got all of our tables now. We've got our view. So our table schema is test3, and table name is posts with authors. And these all say that they're nullable, but I think they are not. So let's see what else we get here. I see. So Postgres thinks that these are nullable. But here, Postgres knows that they're not nullable. Postgres knows these constraints exist. So something about the way we are pulling these columns is missing out on these constraints. So let's see, Postgres query not null constraints on view. It's not really constrained. Postgres view columns show as nullable. Why are columns and views always nullable? Under certain conditions, certain versions of Postgres, they might show up as non-nullable. There is a way to see the underlying nullability with yourself, for yourself. Well, that's interesting. Our view name is posts with authors. Is nullable? No. Information view column usage. So can I join view column usage here? Yeah. So, one of my ways that my rules to live by is nothing is impossible. The answer is going to be out there somewhere. So we're going to join VCU on vcu.column name equals column name and vcu dot table name equals udt dot name and vcu dot table schema equals udt schema. And vcu dot table catalog equals this was udt. It's going to be table catalog. It's like this. Column name is ambiguous, so this has to be columns dot column name is ambiguous, so I want columns dot column name where columns dot table schema and columns dot table name. Almost. So I am make sure. Well, because relation schema, that's part of my variable name. So these names all come from inside there. So can get this working. So what was UDT schema? That's right. The user defined data type. I think I can just do this. Let's do c.udt name and c.udt schema. So this gives me all that, whereas this gives me basically the same data, but with better is nullable. So let's move, just make sure. Column name, move is nullable to the end. You get column name. I don't need this data type. UDT schema, UDT name, column name is nullable, no, is nullable, yes. So I'm getting the same information. Do I need that? No. This has the same information, but I get better information for is nullable. Fantastic. So we'll do columns.column name. Do c.column name. Okay. Or view name. Oh, this is only for views. Where is view name coming from? Okay, so this is something interesting. So I just spent a lot of time merging together the code that collects the views and the tables, and I just came up with a reason why I want to treat those separately. I don't know if you caught this, but I just said so I spent all this time merging these two things together, and now I've got a good reason to split them back apart. Get tables. And we're going to have get views, which is going to be almost the same. But this is going to be different. So we've got all of these, but I want to look at vcu.table schema and vcu.table schema equals test2. Oh, as the underlying table schema comes from somewhere else. Yeah, I'm seeing that. Sorry about that. I don't know what's going on with the network here. I want to look at everything in this view column usage. View schema. I say where view name is that and view schema is, so then here we no longer have get relations. We have get tables for schema name and get views for schema names. Thank you. Where did I spell schema wrong? Gotcha. Yeah, that lag is getting pretty bad. this stuff is looking right. Let me go into to save this. It's missing a lot of things. Oh, I think I've just got stuff out of order. Let me go to generate to these tests. Let's see. Now everything is broken. So let's go to the simplest one. So I'm not getting my table columns now. So let's go investigate what's happening there. I do get tables. What do I get here? So let's do console log tables. Wait, get tables for the schema name. Should be getting that. You get all the relations. Getting something. Let's see about the schemata. I have something there. But I'm not getting the columns out. So what broke down here about columns? Get tables. Test user. So let me see, what did I break here? So select all these things from there. Table schema is test and table name is users. I should be getting values here. I am getting values. So why? Is it not showing up here? Got no columns. Okay. Something's going on with get views. That's obliterating what happened with get tables. So let's look at get views. Oh, okay. I copied this, and this should be from views. There we are. That's working. And so now these are sort of in a different order. So this put post with authors is name is a string, ID is a number, author ID is a number, title is a string, body is a string, author name is a string, author status is a status. Got crazy eyes. Why don't you like this order? I'm going to regenerate the snapshot. Feel generally pleased about everything else. All right, so that makes me pleased with this problem that we no longer have every column is an optional column. And now I want to solve the problem where this status needs to be imported from the other output. Doing cross-referencing data types. So the table types seem okay. We got this PG type to TypeScript type. So what I need to do is I need to figure out which other types are referenced in this type before I go and generate them. So I want to get something like extract enum types that are referenced from other schemas. So we'll say const references enum types. I don't know what this is yet. And we're going to go for what loop are we in here? So I need to do that per schema. So we're going to go through this schema. I say schema dot relations. So we'll do object dot entries for all of these relations. And go through each of them. And then we're going to take that table columns. We're going to go through each column. We're going to say column dot UDT names. We'll say if column dot UDT schema is PG catalog, then we know not a user defined type. If column dot UDT schema equals schema name, we know it's not a reference to another schema. Otherwise, we'll do an else if there. So otherwise, then we know we are referencing this schema. So let's make const referenced enum types will be a set of strings. And if we're here, we'll add udt schema.udt name. Maybe I'll do referenced schemas. If we get that, we will add schema. And then we'll have to do const imports equals reference schemas dot map. We'll Pascal case it, and we'll import Pascal from right next to it. We're going to do import star as Pascal case name. And then down here, I'm going to generate all that source. We'll put the imports first. So we'll get import stars test from ./test.ts. So that gets us, we can import from across these schemas. And then for PG type to TypeScript type, I'm going to change this a little bit. So let's say if we're in PG catalog, then we'll return this. Else, if it's our own schema, then we're not a reference, and we'll return snake to Pascal, the column dot udt name. Else, we'll do schema dot name. And then finally we can return. And that goes real badly for us. So I didn't delete this. And there we go. We have our import test from ./test, and status is read from that. So let's go to our test. Posts with authors is going to start with import star as test from test ./test.ts, and status is test.status. I put my escape on the wrong side of the quote. Double escaping. All right, I'm going to regenerate this because I don't know how to do the escaping correctly. Because I have extra new lines there. So let's just go clean that up here. So of these, I'm joining them, but I'm going to go ahead and filter them. Okay, so what if I do dot trim to take off the leading and trailing white space that I don't need? Now, don't want to trim. Oh, so close. I don't have any dot only in here. With multiple schemas requested, I'm going to filter out. So do filter source dot length is greater than 0. So if there's nothing in here, we're not going to join it together. Uh, okay, because I regenerated this. There we go. Export interface posts. And this one also like that. Should look like that. I'm just going to regenerate this. And with multiple schemas requested, this will regenerate. This looks like what I want. Let's get some log messages out of here that I don't need. Okay. We are generating types. So now let's rename this. So this is the type generator. And let's rename this to be type generator. Well, I don't care so much about that. And I'll make a file. Now this is going to be generate types.ts. And this is going to import. Yeah, I do want to rename this. So generate types, rename that to be type generator. The generate types files will import type generator. We'll make a const main is an async function. Call main. So we will await type generator, and instead of test and test2, we'll make go to the type generator. We'll grab our skip schema. This function, we still like those functions. We just want to use them over here. So the schemas that we want to use are that. We're going to go. Do we need the type from here? Yes. We need exec query. And we'll call this with schemas.map, grab the schema name. So then here, we'll call generate types. We'll do ts node dev type, just make it different. Yeah. So we've got our transpile only respawn generate types. So now we're getting all of our source code for our types for our various files. And we will, let's see, why are we creating source in our file names? I'll leave that be for a second. So we're going to do for const type of types. We're going to say, so I need to make this directory and then write that file out to it. So let's keep this incremental. Let's console log type dot file path. And then let's get a full file path. So we'll do path.join directory name, which gives us the directory name of the current directory that we're in. And I'll have to get the path module. See, as I thought, I've got source doubled up here. So I'm actually gonna have to go to type generator, and let's find source. Here I can do, instead of that, let's put directory name in there. So I don't have to do directory name there. And then I want to get everything but the file name here. So we'll do console log path dot base name file path. We'll have to import path. So I don't want the base name, I want the directory name. So that gives me just this part of the name, so I can make sure that that directory exists. So we'll do await fs make dir. So this will create that directory from the directory name. And recursive just means it'll make as many directories as are required to make sure that this directory exists. So that's a safe way to create a directory. So let's do import fs from fs promises. There we go. We've got this thing as generating types. I would like this to completely remove that directory before it generates them. So we'll do await fs rm directory. We want to remove types. We do there no recursive rm. Recursive true, force true. TypeScript doesn't believe it, but Node does not complain. I guess we don't need those because this doesn't break. So I guess I'm going to be happy enough with that. So we'll remove this directory, create the directory, and then we'll write the source data to it. And then we get our type definitions. Oh man, that is satisfying. Now everything else is going to break because they're all depending on these other types. And my type generator test is going to break because it yeah, so it dumped all these in a directory called types. Yeah, the type generator is unhappy. Filter down to type generator. So I got these paths, made them different. Uh, the trouble there is I probably shouldn't do this because now this test depends on my local file system. So let's go back to the type generator. We'll just say that I guess I don't really need the file path here. I think that's what I want is the schema to be schema name. And so the definitions, instead of a file path, will have a schema, which is string. So then the type generator test won't have a file path, it'll have a schema. Yeah. That makes the type generator happy. I need this. So instead of file path, this will be schema. And so we will join so let's make a directory will be path.join directory name types type.schema. And we'll do the same thing here. So I'll make this is going to be const schema directory is that. So we'll make the schema directory. Oh, awesome. So I just have to make the schema dir is that, and we'll make that, and then we'll write to path.join schema directory type.schema.ts. So now if I rerun, so now to remove that directory, I do need recursive true. Oh, fs.rm instead of rmdir. Recursive true, force true. There we go. So just make sure that everything in that directory is deleted and then regenerate it. So if I delete that by hand and then rerun this, those types get regenerated. And I think I actually want these types, I'm going to move these into the database directory. So it'll be source. This isn't the schema dir, this is the db types directory. Move that up here so that this path can use db types directory. And I'll put that in source db/types. So now the types live along with the database. I can get rid of that directory and move all the type generator code into the database. And this is going to break some things. So that's just going to be right next to it. Type generator breaks because it also just gets that right away. Generate types. Moved over there. So now we'll say source db generate types. And that works great. So everything else, now a lot of other things are depending on those types that I took away. So let's remove, so these are the old types that were generated by the other tool. And now I can update these to import from my new types. And my new types match the old types because all these types are generated from the database. Same with create test data. Can use that. All right, that was long and ambling, but we got there and we get to delete a dependency. So we can say, Kennel, you have served us reasonably well, but you outstayed your welcome. So I'm going to update the db reset code. So let's do ts node generate types. Yeah. So whenever I call db reset, I'm going to also generate the types. So if we do db reset, that'll rebuild the database and rebuild all the types all in one go. Uh, so type generator. It's interesting to me. So I am getting everything that I wanted so far from Cannel. Uh, and I'm sure there's some other, like Cannel probably does more things. There's certain types of things that I don't do. I don't, I still think that I could make this a little tidier, a little cleaner, a little easier to read. But just replace that dependency. I mean, the downside is that like I now have to maintain this code. The upside is that I'm pretty sure that I can maintain this code. The kennel project, I mean, I hit a bug and I spent a couple hours trying to figure out what was going on, and I spent a couple hours replacing it. So I feel pretty comfortable that if I ran into other problems, like I don't know if I would do this in a professional context, because now I just like invented a whole thing that I have to maintain, and I don't know how much I would want to do that, but I'm happy to do it here. All right, my voice. I probably, if I wasn't, I was actually had a really fun time building this. If I hadn't gone on to build this, it probably would have stopped a couple hours ago. So I need to definitely take a rest because my voice is a little unhappy with having been speaking for the past 6 hours. But I think it's just a sign of how much I was enjoying myself building this uh, TypeScript type generation to go from you give me your database and I'll give you type definition files. It's a fun little project. So I haven't figured out my schedule next week, but I'm probably going to pick it up again. Uh, but I don't intend to do this tomorrow. But I'll see you around. All right. Have a good one.